PCG and modularity kind of go hand in hand. You can use PCG to spawn pretty much whatever you'd like, and if you set up modular setups or kind of prefabs, you can just spawn preset stuff and create preset stuff really easily. Today I want to show you guys a few ways of using PCG and reusing it, reusing what it can get, reusing what it can output. So that way, not only are you thinking about what you're spawning, you're also thinking about maybe making a setup for just like certain things and then just spawning those pre-made setups. So with that, let's get right into it. For pretty much all of this, I'll be using this brick kit from Kenny. You can get it for free online from Kenny's website. I'll make sure to link this in the description below. But I don't feel like you have to use these. It works for anything, which is the beauty of it. Of course, for any of this to work, we need to make sure PCG is enabled by going to Edit Plugins, searching PCG, and make sure your procedural content generation framework is enabled. We don't need any of the extra ones. Everything we're doing just uses the main PCG setup. Go ahead and check it on and restart your engine as needed. And for these demonstrations, I have this kind of brick tree. I've gone ahead and assembled it from separate meshes here. And I want to make this a pre-made, basically prefab that I can just spawn everywhere else. Well, this is actually very simple to do. There are a few caveats though. First thing is, this will only use the materials in the content browser. What do I mean by that? Well, if I go into the content browser, you'll see I have these 3 bricks already applied with this green material. This already has brown, this has the dark green. They're not all the same, and I have not overwritten any of the materials on these in the world. If you're just planning to use the regular meshes and assign all the materials in the world, it will not automatically come with. But with that out of the way, how do we actually get it to work? Well, all we need to do is just select all the things. We'll select everything here, then just right click, then go to level and create a level instance. Once you click that, it will ask you for a few things. I'm going to turn off external actors, and pivot type in the center bottom is perfect for the shape. I think that's fine. I'll go ahead, okay. And now I can go ahead and save it. I'll save it as li for level instance underscore brick tree, and then hit save. At this point, right in this level, you will see you have a little icon here, which is the level instance icon. And this whole thing now on the right here, you'll see is under level instance. So that's cool, but we're not here to use level instances. You can though, at this point, just drag out the level instance and spawn it this way. The thing is, we don't want to be spawning level instances, at least for something like this, because in the end, every single one of those level instances is not instanced throughout the entire graph then. And we want it to be all instanced together. So let's spawn this in an instanced way. So I'm going to right click and grab ourselves a PCG graph. I'll make an empty graph here. I'll call it PCG underscore brick trees. I'll just drag it out into the world somewhere, just like so, and then I'll open it up. And now with the graph open, you might think, well, I just take the level instance and bring it in, right? No, you cannot bring the level instance in. But thankfully, all you need to do is right click on the level instance, go to asset actions, and all the way at the bottom here, create PCG assets from levels. You can do multiple at once. Go ahead and select it. I'll put it in the same place, hit save. And now we have an level instance brick tree underscore PCG, and this we can actually just drag in to our world. And there it is. So now we have the root location and all the points. So if we wanted to, from the points, I could just use a static mesh spawner already, but now I need to specify what am I spawning. Well, from this, if I was to press A here, by the way, make sure it is in the world when you do this, and I scroll to the right here on the bottom, I can see, oh, this has a mesh attribute, and that's the meshes that have been applied. So all we need to do is change on the static mesh spawner from mesh selector weighted to by attribute. And the attribute is mesh. So we type that in, and you'll see, oh, there it is. There's the little guy. And if I go ahead and move it, you'll see that, well, it doesn't come along. It is small, just like we had before, but it doesn't come along. So what I want to do is make sure that it comes with the object, so that way I can place wherever this graph is, will be where the tree is. Well, for that, we can just use a simple copy points node. I'm going to copy the points from this PCG setup to the location where we are. To do that, all we need to do is right click, get actor data. We want the spatial actor data. And here, I'm just going to keep it on self. But instead of parse actor components, I'm going to do get single point. So we just know the singular location of this graph, and we can just use that as the target and output that in the static mesh spawner. But here's the thing. Our actual volume here, it has scale. By default, it comes in as 25 by 25 by 10. And if I go ahead and scale this more, I don't actually want to scale the actual tree. So we can adjust for that. On the copy points, we have scale inheritance. We do relative, source, or target. Well, I want to keep the source scale, so I select source. And you'll see, well, that didn't really work either, because now the scale is kind of, well, it's the right scale, but it's not in the right place anymore. If I change scale to target, well, then we get the thing we had before. The easy solution, honestly, is after the get actor data to just use a apply scale to bounds. So whatever scale we had here on the original actor, which is the PCG graph bounding box, that scale, apply it to the bounds instead. The bounds being basically what controls the size of the point, but not the scale of the point, if that makes sense. So basically, when we do this, you'll see there it is, a little tree in the right spot, and as I move it, it is staying where we want it to. Fantastic. So now we actually can start using this. And instead of get actor data, for example, we can just do a create points grid, and I'm just going to set it to be 32 by 32 in the X and Y. In my case, that is the size of that foundation, basically, that I want it to be spaced at. And then I can go ahead and plug it in here instead. And now we can take a look, and there we go. There's our grid. That is looking pretty good. And one thing to note here is if you deselect it and reselect it, you'll see there's the instance static meshes, and it's just per brick type. So every single one of a certain brick is instanced within this graph. So all of these are instanced, all of these are instanced, right? You can see all of these circular ones are instanced. So instead of each one individually being instanced, it's now working all together. And from here, we can customize any way we want. Just note, if you were going to prune points, don't prune them here, because if we do a select points, so regular select points here, which is just going to prune a bunch of the points, and we plug it in here, we're now using the points that were here, which means there's a lot of points that are all separated. So we kind of get this, and you probably don't want this. If you want to just now spawn it only in certain locations and prune it, instead of putting it here, you're going to want to do select points here, right before the target. By doing it before the target like this, now the actual place where it's being spawned has been pruned, and you can see here, now we have this nice little setup. Awesome. Now let's say I'm really happy with this. In fact, I want to reuse this setup now in everywhere else. Let's say I've made, instead of one tree, a little batch of trees. Now I want to use this batch of trees in everywhere else and scatter them. Well, we can just transform this regular graph into a subgraph, and think of subgraphs like functions in a blueprint. They can just exist inside of another graph, and they will execute just what's connected to it and output what do you want. Now, before we convert this graph into a subgraph, it is important that you actually remove it from the world if you still have it there. Because if you keep it in the world and it becomes a subgraph, it's going to be looking for an input. And if it doesn't have one, it's going to mess up and it's all going to crash. So what I'm going to do is just select my PCG graph and just delete it. And now we can go ahead and set it up to be a subgraph. So for that, I'm going to make use of this input and output. So on this input, I can just open up the pins in the detail panel. I'm going to say allowed type, I want points, and pin status, I want required. Basically what advanced does is it just automatically hides it. Normal and required do not. And required is there. So you have to plug something into that pin for that node to work. And considering that it's going to be a single node, you could leave it at normal, it doesn't matter. But if you had, like, let's say 5 nodes, and you needed all 5 plugged in for it to actually execute properly, you might want to set them to be required. I just got in the habit of setting it always to required. So awesome, we have this input, and for the output, I'm going to also change the allowed types from any to point, and pin status to normal. Again, so we always see the output. Now basically what I want to do is, wherever this point grid is, copy it to wherever I specified here. So I'm going to use another copy points node. The source is actually going to be the grid, and the target is going to be the input points. So go ahead and copy the grid to wherever I've specified, and then this will then go into the target. And I can leave it here. We don't have to use this output. But if I just left it here, that means everywhere where this graph executes will be its own kind of standalone spawner. And we can just make use of a global one that, again, wherever we spawn now, these batches will all be instanced together. So instead of having it plugged into the static mesh spawner, I'm just going to plug it into the output here. So just like so. So we have an input and we have an output. And now let's make use of this. Back in the content browser, I'll right click, grab ourselves a new PCG graph, an empty graph, and I'll call it just PCG Brick Forest. And this one, I'll go ahead and just drag out into the world, and then I will open it up. So here we are in the brick forest graph, and really we can just grab now these PCG brick trees and just drag it in, and we can select subgraph. So now in the subgraph node, you'll see in the detail panel, we have it selected and we have our in and our out. So if I just did a create points grid node, just like we were doing before, but this time, let's say I want the extents to be 3000 by 3000, and our cell size here will be the size of the grid that we just made. So in our case, we're using a 500 by 500 grid, so that's what we'll use. That's gonna go into the brick trees here. And then just like before, we can just copy this static mesh spawner that's set to mesh here, copy it, and place it into this main graph, and then plug it in here. And if we take a look, there we go. It has now been copied to all of those locations. And again, just like before, if we wanted to, we can now use the select points node and prune some, and then use this graph. And there we go. We now have the same thing as before. The only thing is, when I move this, right, it moves back into position. We don't want that. And that's because the create points grid here is set to global. I want it to be a local component. And in fact, on the original one here, when using the create points grid, I also have it global. Let's set it to local component. This basically makes it so it'll move with the graph or the blueprint that it's attached to. So now I can just go ahead and move it. And as I move it, it'll randomize. And now I have these clusters wherever I would like. The only thing to note here is it's the same cluster every time, right? If we look here, you can see these two are right next to each other, here, 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 and here, right? Everywhere, it's always the same cluster. And also, I think we got the distance a little bit off because we have some overlapping. So in fact, cell size probably needs to be double, so 1000, because we were talking about radius before. Because of that, I'll increase the select points ratio here to like 0.6. So there we go. So now you can see it's now equally apart. But again, it is the same one each time. Because this is just a subgraph, we're always going to spawn the same thing. Now, you can still move these around. So here we can use, for example, a transform points node, but note that it'll move the entire grid. But let's say for fun, I set 0 to 360 rotation. It will now randomly rotate each one of these now as the whole group 0 to 360. Because imagine that this subgraph is effectively a single static mesh. It's not literally static mesh, but if you think of it as just a single object now, it'll start to make sense why it's all coming together as one. You can randomize it. You can use loops, for example, but that's not the point of this video, is to show you how to reuse graphs. So now we're using the level instance into PCG Data Assets, and we're using subgraphs. But you can also make PCG instances and customize controls. So for example, here, I don't have anything that's actually exposed. But let's say I want to dynamically change the number of points here. Well, I can open this up and you'll see here, there's an input for the seed and the ratio. Let's say I want to modify this ratio. Well, in the bottom left, I can go to graph parameters, hit plus here. It'll get us a float by default. So now I can click here and press F2 to rename. Now let's call this a ratio. Nice and simple. I'll give it a default value of 0.5 here. Now I can click and drag it right into the graph here and plug that into ratio. So cool. We now have a parameter or a variable effectively controlling this. And if we go back into our graph here, I can scroll down to the PCG component, open the parameter overrides, and here we can control over this. Let's say 0.2, 0.6. You can see it's changing the amount we see. But you can also predefine a few, so you can just drag it in with the right settings right away. So if you have a very customizable setup and you want to kind of save those settings, all we need to do is go here to the PCG brick forest that's spawned in the world, right click on it and click create PCG graph instance. It'll create an instance for you. You can go ahead and rename it if you need. I'll open it up and in here you'll see there's a PCG graph and you'll see parameter overrides. So now I can specify, you know what? This instance is going to be configured to have 0.8 ratio, just like that. So now in this instance, I can just drag out the instance and you'll see here automatically it is set to 0.8. Also, this one was my mistake. I actually set the inner subgraph one to also be a local component on the PCG brick trees. In fact, this one actually needs to be, instead of a local component, a global component. Because if you do local, then it will do double offset, which is what we're seeing here. So back to global, you'll see that now fits perfectly inside the graph. But you can see this is now always by default at that value. And if we want to, we can select the PCG component and you'll see ratio here by default is 0.8. So we can change it back to whatever we want, for example, 0.5. And if we go and hit reset, it'll go back to the instanced version. So just like that, we can have presets of different graphs automatically configured. Now, for this, it's not super useful, but if you're setting up things from a data asset and you want to configure things and have them pre-made, you can set it up to have the right data assets with the right values, and then they'll just be click and drag them in as instances automatically. You'll have their own kind of predefined modular setup for full PCG graphs, which is very nice. The last modular use case I want to show is for actual nodes, because you can save the settings for nodes even. So for example, you know how there's the difference node, and by default it's set to minimum. So many times you want the difference here to not be minimum, but rather binary. Now, when I set this to binary, this one will be binary. Also, by the way, it's not updating because just nothing's being plugged in. As soon as I plug something in, it'll realize it needs to be updated. So it'll reset to binary. So don't worry about what it says here. Note here. But let's say I just want to have this as the preset. Again, not super useful for the specific node because it's just one setting. But if you have a node where you have, for example, let's say a spline sampler, well, this one has a bunch of settings here. So you can see here, look at that. So many settings. You can preset all of these however you'd like. Let's say I want to do on interior and unbounded. I want that to be the default. Instead of having to set that every single time, I can just right click on this node and click export nodes to PCG settings. I'll go ahead and save it like spline sampler on interior, hit save. And now what's cool is I can go to the content browser and you'll see it right there. All you do is grab it, drag it in, and now we have the option of copy and an instance. Let's do a copy as well as an instance. I'll show you the difference. Second one here is going to be instance. So this one looks different, but don't worry. So what's the difference? Well, on this one that we copied in, you'll see that it is set to on interior and it is set to unbounded. Same thing with this one, but it looks a little bit different and it has no settings here whatsoever. The nice thing about the instance is you can have as many of them as you want, anywhere at all, and it uses the settings from here. So if I go ahead and open this up, this is the spline settings, and I can just globally change it for everything. So instead of on interior, I can set it to be on spline again. I can make it not unbounded, and it will apply it to each one of the 3 settings here automatically. So effectively, it is like a subgraph, where if you were to change something in a subgraph, it'll set it up to be like that in every place you're using the subgraph, but this is just for the singular node. The one that you copied does not get affected no matter what. This will still be whatever you had. It is just like the regular node, except it has preset configuration already set up for it. At any time, I can just change the settings here. So it's quite convenient in that regard. But those are kind of the main ways of reusing things in PCG. Level instance stuff to take things from the world and just have pre-made things being spawned in. PCG subgraphs that allow you to take a preset configuration and reuse them in other graphs like functions. PCG instances to be able to customize the existing graph and give it preset configurations, and being able to save the different settings for individual nodes that you might take a while to configure the way you like to every single time. So hopefully this has been helpful for you. Now there's not much here, but nevertheless, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything else is down in the description below as always. And if you're still just getting started with PCG and getting your bearings, I highly recommend this video to get your foundations in place.